Hi everyone, this is Annalie, and I'm presenting to you Prism.ai, an AI research engineer for computer vision built with Codex and GPT-5.6. Now let me show you what was the problem and how I solved it. Every computer vision problem starts with a manual slow run of, for example, there are stages like dataset analysis, then literature view and finding the latest papers, research papers, and then the experiment plan, and then the actual code write-up. Prism.ai compresses this all into a one workflow. Let me show you how. It all goes through a six connected stages or agents, you can say. Number one is dataset analysis, then literature review, experiment planner, code generation, research report, and a research assistant. Each agent has access to outputs of the previous stages, and all of these are grounded on the real data. Now, how Codex was the helpful tool and the helpful companion in this project. Every one of the six stages, the auto chaining pipeline of our main agents and the auth and the UI UX, everything was powered by Codex. And the area where Codex really shined is the reasoning power of the Codex and the GPT 5.6. It really helped me to like decrease the number of my actual agents from 7 to 6 based on the time frame we had for this hackathon. Now let me walk you through a project demo. This is the main actual landing page of our project. Here is your dashboard. Now if I go to a new project, we will have the option to name our dataset. For example, I'm calling the dataset which I'm going to upload is the brain tumor detection. So I'll choose the zip file of the data which will contain all the images from my dataset. And now I'll start this analysis. It will upload the dataset to the backend and then it will start the analysis. Each analysis will go step by step. And it will take around 3 to 4 minutes for the full 6 stage analysis of the whole process. And that task usually takes around more than days to basically. So now you can see that dataset analysis work has started, then the literature review and all these will come. So I already, because this takes few minutes, so to reduce the time, I already have the pre-run analysis to be shown to you. So if I show you this, it is already completed. And you can see that the first agent output is like this. You will have the class distribution, the imbalance ratio, total number of images, duplicate images also mentioned. Then the literature review, you will have the latest papers. You can see that this is from 2022, 2024, 2024, and this is from 2025. And they are all the related to our data set. You can see that brain tumor MRI classification, right? And then we have the experiment plan where you will see that the first step is the pre-processing. You will do these many steps as suggested by our AI GPT 5.6 is the main brain here. Then we have the augmentation step. And after these, you will have your main architecture, which is suggested by our AI, that is DenseNet in this case, okay? And it is shown the alternatives also, and from which paper it took this idea. That paper is also referenced right here, which you can access and read more. Your data split, it is also recommending the everything like evaluation matrices, which you will like display to your paper loss functions and expected challenges, and their mitigations are also mentioned. So one can read these all stuff. Then you will have the code part. You will get the repository of your code, train.py, config, requirements file, and a README also. Nicely structured everything. You can download it as a zip folder. And then a report, a research report for your project and your findings. Okay, you can include the findings once you run the code, but other than that, everything is there. Dataset analysis, the related work, that means the literature reviews also there, methodology, pre-processing, everything is there.